Good morning, students. Next reaction is Friedelcrafts alkylation. In this reaction, so here we are simply alkylating the benzene. Alkylation of benzene takes place. So here alkyl groups are attached to the benzene. So here there is a scientific given Friedelcrafts. So anyway here the alkylation, for example, methyl chloride when reacted with the benzene in the presence of aluminum chloride, Lewis acid. So we are getting the toluene or methyl benzene. So alkyl is commonly it is a alkyl benzene. If so that is methyl benzene, or otherwise common name for this one is toluene also. This one is a toluene. So this is the alkylation. So in our general mechanism, so mechanism of this one, first of all we should produce the electrophile. After that electrophile will attack the benzene, and after that formation of product takes place. So here electrophile is a methyl chloride. So this methyl chloride is converted into electrophile. The carbocation formation takes place in this case. So here the carbon, this is the methyl chloride, when reacted with the Lewis acid AlCl3, aluminum has a vacant p orbital, so that's why the chlorine will react easily with the aluminum, and there is a bond found between the chlorine and aluminum because the aluminum has one empty p orbital, and with these electrons there is a reaction between the chlorine and aluminum. And what happened here? Slowly the bond found between the chlorine and aluminum, the overlapping takes place, the orbital overlapping takes place between the chlorine and aluminum. As a result of this one, so here the chlorine is losing its electrons and aluminum is getting the electrons, and finally chlorine is getting positive charge and aluminum is getting negative charge. So see here chlorine is more electronegative compared to carbon atom. So finally what happened? When chlorine is getting positive charge, immediately the bond between the carbon and the chlorine is being broken. So that's why finally carbocation C plus is produced and AlCl4 is generated. After that this AlCl3 again undergoing dissociation into AlCl3 plus Cl minus. Here the formation of carbocation takes place. This is simply methyl chloride. In case of propyl chloride or methyl chloride, the same thing is happened here. Anyway, generation of carbocation takes place. It is an electrophile now. It is an electrophile. Electrophile always needs electron. In case of in our first nitration reaction, NO2 plus is an electrophile. Next after that SO3 is an electrophile, or SO3H or SO3H is an electrophile. Now in this case, now in the third reaction, methyl CH3 plus is an electrophile. All these molecules are carrying positive charge. Either it is a neutral molecule or positive charged molecule. They act as an electrophiles because see here they are having positive charge. In case of carbocation we have positive charge. In case of sulfonation, there also sulfur has positive charge. In case of nitration, N has a positive charge. Even sometimes neutral molecules also act as a electrophiles. Electrophiles always they love electrons. They need electron, and that's why they are searching for the electrons. Now in this case we know the benzene acts as a base. The weak base, because due to delocalization sometimes this pi electron, whatever the pi electrons present inside the benzene, 6 pi electrons, these 6 pi electrons are undergoing delocalization from one carbon to another carbon. As a result of this one, all the carbons are getting octet, and this molecule is more resonance stabilized. So each and sometimes one carbon get the 6 and another carbon is getting octet. So finally what happened when this carbon is getting 6 that means this carbon has 6 electrons, other carbon has 8 electrons. Immediately what happened? These electrons are shifting from here to here. So what happened? Again this carbon is getting octet, but this carbon is getting 6. And finally what happened? These electrons are shifting from here to here. Like that, one carbon is getting the 6 and another carbon is getting the octet. So here like that, these carbon atoms these pi electrons are delocalized inside the benzene, and every carbon atom is getting a octet, and as a result of this one, this benzene is more stabilized. So that's why, anyway, now see here, when benzene is undergoing delocalization, we are getting a negative charge. The benzene is getting a negative charge on the ortho and para positions. So this is here we can clearly see at ortho and this is ortho position and para positions. Ortho and para positions are getting negative charge. And when electrophile meets electron and benzene has electrons, so there is a reaction between the benzene and the electrophile takes place. CH3 plus and it acts as an electrophile and formation of the attack of electrophile takes place. And finally, when this bond, see here, when the pi electrons are shifting from here to here, when pi electrons between the carbon 1 and 2, these pi electrons are shifting towards the carbon 2. Carbon 1 has only 6 electrons. So this is the positive charged carbon atom. So finally what happened? We explained in our last class also, the shifting of bonds takes place, and finally we are getting positive charge at the third position, meta position. And finally in the fourth position, the third step of the reaction, that is the elimination of hydrogen atom or formation of product. What happened here? At the third position we have the positive charge and we have the base. Base is pulling this chlorine, Cl minus is pulling the hydrogen atom. The bond is formed between the carbon and the chlorine. So carbon and chlorine, carbon has a sufficient amount of electron and H is now between the carbon and hydrogen, the bond between the carbon and hydrogen is broken because slowly the bond between the carbon and the chlorine is a bond formation takes place between carbon and chlorine, hydrogen and chlorine, and the bond dissociation takes place between the carbon and hydrogen. So finally what happened? Whatever the electrons that left from the hydrogen left, that electrons are shifted between these two carbon atoms, second and third carbon. There is a bond formed. So finally, the hydrogen will react with the Cl minus. This Cl is because here aluminum. This all reactions happens in one reacting vessel only. So whatever the chlorine atoms are formed, that chlorine atoms are withdrawing, pulling this hydrogen atom, and formation of HCl takes place. But here what happened? There is some limitations of Friedelcrafts. So what are that limitations? When benzene is undergoing methylation in the presence of aluminum chloride, Lewis acid, of course there is a formation of methyl benzene, but this reaction proceeds to another methylation because so now this is a methyl benzene and this CH3 is a ortho para director, that is electron donating group. When electron donating group attached to the benzene and it is pushing electrons and ortho and para positions are getting negative charge, we will see in the reactivity and orientation class. Anyway, this is benzene, methyl group act as a electron donating group and this electron donating group is pushing electrons and here ortho and para positions are getting a negative charge. And as a result of this one more CH3 plus, again one more CH3 plus will attach to one more ortho or para positions. See here, like that. See in this case, this is only one methyl group and this reaction proceeds, again one more methyl group attached and this reaction further proceeds and one more methyl group is attached. Because this is CH3 is ortho para director. We will see what is ortho para directors in our coming classes. Anyway, when this methyl group is an ortho para director means ortho and para positions we have negative charges. That means it is pushing electrons and ortho and para positions are getting negative charges. At that time, whatever the methyl CH3 plus are formed during the reaction, during the dissociation, that CH3 plus are reacting at para and ortho positions. So that's why here this reaction is further proceed. And there is a polymethyl groups are attached on the benzene. There is a polymethyl groups. So number of methyl groups may attach to the benzene. So that is one limitation. And another one is if there is an electron donating. See, this is an electron withdrawing group. If any electron withdrawing group attached to the benzene, in this case the methylation or alkylation of this molecule is difficult because if you want to attach alkyl group to this nitrobenzene, this is the nitrobenzene. This nitrobenzene contains NO2 group and this NO2 group is an electron withdrawing group. it is always withdrawing electrons from the benzene. What happened here? If you see the resonating structure, this nitrogen, because this nitrogen has two more electronegative atoms, and these electronegative atoms are always withdrawing electrons from the nitrogen. This nitrogen atom is withdrawing electrons from this carbon atom. So finally what happened? These electrons are moving towards the carbon and nitrogen. There is a double bond formed. So what happened? These electrons, whatever the electrons between the third carbon and fourth carbon, this electron density is moving between the carbon and nitrogen. Now that electron density is moved between the carbon and nitrogen. There is no electron now on the third carbon. So third carbon is getting positive charge. So what happened? If third carbon is getting positive charge, immediately adjacent carbon is donating electrons, and this bond is shifting between the first and this bond is actually present between the first and second carbon. But now the bond is shifting between the second and third carbon. But what happened? First carbon is getting positive charge. If first carbon is getting positive charge, automatically the adjacent carbon atoms, whatever see here, sixth and fifth carbon, there is a double bond. Now this double bond is shifting between the sixth and first carbon. But finally what happened? Fifth carbon is getting positive charge. Due to presence of electron withdrawing group like NO2 or carboxylic acid or cyanide groups, these electron withdrawing groups are pulling electron from the benzene. As a result of this one, benzene is getting positive charge. Benzene is getting here, this is the positive charge, this is the positive charge, and this is also positive charge. As a result of this one, what happened? Benzene, due to electron withdrawing groups, there is a formation of positive charge appeared on the molecule. Here also benzene is suffering from lack of electron, and at the same time electrophile also need electrons. Electrophile also need electron, benzene also need electron. This is also positive charge. In the benzene we can see the positive charge is displayed on the benzene. And here also positive charge is there, and the coming electrophile also need a positive. The electrophile also has the positive charge. Both the positive and positive charges, they are undergoing repulsion. So that's why here in benzene electron withdrawing groups containing benzene is not undergoing alkylation, because electrophile needs electron. This molecule also needs electron. Both the positive and positive charges undergoing repulsion. So that's why here electron withdrawing groups containing benzene do not undergo alkylation. It is very difficult to participate in alkylation reaction. So next one more limitation is when benzene, this is the propyl chloride, when benzene is undergoing alkylation, when this propyl chloride reacted with the aluminum chloride, we are getting the propyl cation. This is the propyl cation. So when this is the propyl chloride, when reacted with the aluminum chloride, the chlorine reacted with the aluminum, same like here we discussed, and formation of cation takes place. And AlCl4, automatically AlCl4 is again undergoing dissociation and the formation of AlCl3 plus Cl minus. But what happened here? This propyl cation is undergoing rearrangement reaction. This is the rearrangement reaction takes place. Rearrangement reaction takes place. Now this is the propyl cation. We can see CH3, CH2 and CH2. This is the propyl cation. Here hydrate shift takes place. With this total electrons, this hydrogen is carrying its electrons, and this entire hydrogen shifting from second carbon to first carbon with electrons, hydrate, H minus. Now what happened? See, this is an adjacent, this carbon has positive charge, and this is a carbocation. Adjacent we have the carbons. Now what happened here? Hyperconjugation takes place. Now this hydrogen along with electrons, this hydrogen is moving from second carbon to the first carbon. Now what happened here? Formation of carbocation takes place at a second position. Now the second carbon has lack of electrons. In this first case we have first carbon do not have sufficient amount of electron, but due to rearrangement of atoms, now the second carbon lost its electron. Now the carbocation this is the primary carbocation. Now primary carbocation is converted into secondary carbocation because of this hydration. Now what happened? This secondary carbocation now attacking the benzene. So we will get two types of products. One is if it is a linear N-propyl cation. This is a N-propyl cation. N-propyl cation. If N-propyl cation attacks the benzene, this product we can see. If here this is a isopropyl cation. This is the isopropyl cation. If isopropyl cation. If isopropyl cation attacks the benzene, we will get this product. Carbon has hydrogen. This is the positive charged carbon previously. This positive charged carbon reacted with the benzene at our para position, and this carbon has two CH3, CH3 and CH3. So this is the actually we will predict one. We will if you want to prepare N-propyl benzene, this N-propyl benzene is converted into isopropyl benzene also. So that is also one of the limitation of Friedelcrafts. So anyway, Friedelcraft alkylation is used for the alkylation of the benzene, and this due to we can add any type of alkyl chains, like here CH3 is an alkyl chain, and here propyl is an alkyl chain. Otherwise we can also add butyl cation also, butyl alkyl chain also. So this Friedelcraft reaction is used for the alkylation of the benzene.